Alright, hello and welcome to today's lesson. This is Mr. Ludden, and today we're going to have a look at the modulus, which is also called the absolute value, and we'll have a look at how that comes up in Leaving Cert higher level exam type questions. As always, any of the notes that I go through in today's lesson will be in the description below, so do take a look at those. And I'm also going to pin a comment to the top of the comment section with timestamps of the various exam questions that we go through and just anything else important that's in the video. We're going to start in a minute by looking at what the modulus actually is, how your calculator is going to help you out during modulus questions, how it looks like in a graph, and we're also going to explain the meme in front of you there as well as a special treat. And then in a couple of minutes time we should be fit to attack two exam type questions, one dealing primarily with just numbers and one bringing a graph into it as well. So let's start. If you have your calculator handy, the button that's going to help you out is circled in red up at the top left if you have a Casio calculator. If you have a Sharp calculator, it should be somewhere similar. And the ABS there stands for your absolute value. Now if you click that, you're going to get two lines that comes up. The technical name for those lines are bars, and what you're going to do for me, just to, I suppose, investigate what those bars actually do, you're going to put 3 in the middle of those for me, and you're going to press enter on your calculator, and you're going to get the answer 3. So far so good. Those bars are just acting like brackets. However, if you reset your calculator and click that again, click the ABS button, and if you put -3 in, you're going to get that is equal to 3, as in +3. So we have now sort of stumbled across what those bars actually do, what your absolute value actually is. It's going to be the positive value of whatever is inside your bars. So if your number is positive already, so like the 3 here, you don't need to change it at all. However, if your number in here is negative, it is going to change to the positive value of that number. And you might ask, well, why do I need that? Like, why is that important? And I suppose the example that I often give is, let's say you had a distance question and you had a number line. And I'm just going to quickly sketch a number line here. 0, -1, -2, -3, -4. And you were asked to get the distance from 0 all the way back to -3. A common mistake people make is they would say that the distance is -3 units. And while the 3 here is fine, like it is 3 units, you can't have a negative distance. So that's where our absolute value comes in. It always takes the positive value of a negative number. So this right here is actually incorrect. Your answer is 3 units, even though you're working back the way on your number line. So that's the main idea behind the absolute value. But when we have a look at our exam questions as well, and when we've got some algebraic terms in there, we'll see how that behaves. Just before we have a look at that, I'm just going to give you a couple more examples. Let's say you've got -7. The absolute value of that is going to be 7. Let's say you've got the absolute value of x plus 1. Well, that's going to be x plus 1 because that's a positive x plus 1 there. Let's say the absolute value of negative x plus 1. Well, that's going to be x plus 1 as well. Remember, this thing here inside your bars, that is a negative number because of this negative here. But remember, your bars, which signify your absolute value, will only take the positive value of that. So just be careful with that. Now, just to explain the meme, I'm going to give you 2 examples of one where this is correct and one where it's not. Let's say x was 3. Let's just say, for example, x is 3. then y is going to be the absolute value of 3, which is 3. So y is equal to 3. So what we have is that x is equal to 3 and y is equal to 3. So our second part of that, y is equal to x, is correct. So all well and good. However, if we say start from the start again, and if we say that x is a negative number, let's say x is, let's go minus 3. All of a sudden we've got y is equal to the absolute value of x. So y is equal to the absolute value of minus 3. And as we know, the absolute value of minus 3 is positive 3. So my y is equal to positive 3. So if I write out what I have at the end, I've got x is equal to minus 3, but my y is equal to positive 3. So that means my statement here at the very end, y is equal to x, in this scenario over here, is not correct. So you can see the dilemma that the pirate has here. This statement is correct in one way, but not correct in the other. And in an exam situation, you would have to be aware of both of these scenarios. So scenario number 1 over here and scenario number 2 over here. Otherwise, if you're not aware of both scenarios, you might end up losing some marks. And we will be getting on to some exam questions just after I show you what your absolute value looks like in a graph. So for that, I'm going to use GeoGebra. If you haven't used GeoGebra before, it's a fantastic resource for anything to do with geometry and trigonometry. It will graph any of your questions for you, so it's great for checking homework or getting to an answer, or just messing around with graphs, really just seeing how they interact with each other, and when you change certain numbers, how they move. So as you can see in front of you, in the input bar over here on the left hand side, I have plugged in y is equal to x minus 2. Now I haven't got anywhere near my absolute value signs yet. I'm going to do that in my next graph, but my green line here, well, I've actually gone over it in red now, but the green line there is the graph that is associated with that function. So that's going to extend on all the way up to the top right there and all the way down to the bottom left there, and it's going to keep going. I'm going to show you one more graph, and it's going to be nearly the exact same as what I have in the left here, except I'm going to put the absolute value signs either side of my x minus 2. So I'm going to put the bars either side, and we're just going to see how that changes. And that is this graph here. So you'll notice that I've got y, just in case you're wondering, that f there, that's just telling you that the function is y is equal to the absolute value of x minus 2. That f there, I'm just going to mark it out just so we don't get confused. What we have here is y is equal to the absolute value of x minus 2. And you'll notice in the same way as my other graph, I'll actually put those side by side so you can see them better. For my original graph, just over here, let me get rid of that. Your graph goes all the way up to the top right and all the way down to your bottom left. So it goes into your negative numbers on your y-axis. However, your graph on the right hand side, so over here, goes all the way up to the top right, but as it starts coming down here, you notice it hits the x-axis and then reflects upwards. So you'll notice that the y values are never negative. And you'll notice that that lines up with what we were talking about before, because if you look at your function up here, y is equal to the absolute value of x minus 2. Well, this here is always going to be positive. So it's no surprise that on my graph, my y values now are always going to be positive. In other words, this graph here never goes down below the x-axis. Just one more thing to be aware of. If I was to extend this line all the way down, and if I was to compare it to the line that's gone all the way up here, it's actually reflected in the same angle. So like the angle from here to here, let's just call that alpha for now, is going to be the same as the angle from here to here, which is alpha. Another way of looking at this, and I'll just get rid of that, is that this angle here is going to be the same as this angle over here. So just something to be aware of. It might help you out in a question or two. But just so you know, like, and I'll just get rid of my red lines here. This line here comes all the way down and then bounces back up. The main thing we're looking at here is that it does not go down below the x-axis, because this part here always has to be positive. So I'll just take away all my red marks, and if you want to pause the video and just have a look at those, that's what this will be here for. And if you want to take a minute to actually go onto GeoGebra and see if you can put in those graphs, now would be a great time to do that too. If you are looking for the absolute value sign on your keyboard, if you press Shift and this button here, the one with the backslash on it, that will give you your absolute value signs, so your bars. But just be careful, on different keyboards, that button there can sometimes be a bit further over to the left, so you might have to go searching for that if you don't have a keyboard that looks like this one here. Okay, so that's our intro. We had a look at questions involving just numbers, so like something like that, we got an idea of what was going on there. Then we looked at our graph of something to do with the absolute value. Now let's look at an exam question. And this question came up in 2016 on your paper 1. It was your question 2A, and they asked you to find the range of values of x for which the absolute value of x minus 4 is greater than or equal to 2, where x is a real number. So there's two ways about going about this question. Seeing as the number inside your bars here could be positive or negative, like there's two sort of, like the whole thing here, we're talking about the x minus 4, like it could be positive and it could be negative. We've got to sort of counteract that in order to solve this problem. So there's two ways of doing this. I'm going to show you method 1 and I'll show you method 2 as well. Method 1 would be to square both sides, because if you think about it, just a bit of background here, if I square the number 6, I'm going to get 36. If I square the number minus 6, I'm going to get 36 as well. So I'm going to get the same answer. So it doesn't matter if this number here is a positive or a negative, I'm still going to get the same answer. And same over here. I don't know whether this is positive or negative, but I do know if I square it, I'm going to get a positive number. So that's exactly what I'm going to do. So I'll just get rid of my rough work here. And my first line is going to be x minus 4 squared is greater than or equal to 2 squared. So all I've done is squared both sides. Now if I squared both sides, you've officially sort of counteracted what the bars are doing. And your job now is just to tidy this up. I'm going to take this opportunity just to let you know that I've done a video on algebraic inequalities, dealing with questions very similar to this. If you feel you need brushing up on that, there'll be a link in the description below, so do take a look at that. But for now, we'll just we'll sort this out. X minus 4 squared is x minus 4 times x minus 4 is greater than or equal to 2 squared, which is 4. X minus 4 times x minus 4 is going to be x squared minus 4x minus 4x plus 16 is greater than or equal to 4. Then on my next line, I'm going to have x squared minus 8x plus 16 is greater than or equal to, oh, I've had a 0 there, apologies, that shouldn't be a 0, that should still be a 4. So greater than or equal to 4. If I take 4 away from both sides, I'm going to have x squared minus 8x plus 12 is greater than or equal to 0. And now I just need to factorize my quadratic here. You can do that using your guide number method or your quadratic formula, which some people call your minus b formula. I'm going to sort of quickly use my guide number method. I'm going to end up with x minus 2 times x minus 6 is greater than or equal to 0. These right here are my factors, F-A-C-T-O-R-S. We want to find out what my roots are. So for my roots, I'm going to take one of my factors, let it equal to 0, or the other factor, x minus 6, is equal to 0. For this one here, if I add 2 to both sides, I'm going to get x is equal to 2. And for this one over here, I'm going to get x minus 6 is equal to 0. If I add 6 to both sides, I'm going to get x is equal to 6. So in order to find out my range of values for which my quadratic, not that one, this one here, my quadratic is greater than or equal to 0. I'm just going to do a quick sketch of the graph here, and I'll do it over on the right hand side. It's not going to be perfect, but it's just going to give me an idea of what's happening. So my roots are going to be x is equal to 2 and x is equal to 6. So let's go 1, 2, 3, 4, 5, 6. So x is equal to 2 and x is equal to 6. I know that my graph is going to cross my x-axis at those 2 points, and this is my y-axis. And I know that my graph is going to cross the y-axis at the constant part of my quadratic, which is the plus 12. So if I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I know that my graph is going to cross, let's just label those 12, 2, 6. I know that my graph is going to cross the y-axis up at 12. And I know that seeing as my x squared is a positive x squared, I know that my graph is going to be a smiley face or a U shape. So if I was to sort of sketch out this graph, it would look something like this. Now again, that's not perfect. Your actual graph will look like this. And again, I got this by plugging in my quadratic into GeoGebra. So my quadratic was x squared minus 8x plus 12 is greater than or equal to 0. So again, that was a quick sketch, this bit up here. It gave me an idea of what was going on, but I'm going to continue working with this one, obviously, because it's a lot nicer to deal with. So for this, you're trying to find out where your quadratic is above 0, and that 0 indicates your 0 on the y-axis, which basically your question is asking you where is your graph above the red line, above the x-axis, and it's going to be for any values of 6 onwards, so 6 and upwards, and any value from 2 and backwards. So the way we write that in maths is any value for, greater than or equal to 6. So when x is greater than or equal to 6, and sorry about that, my hand slipped. Where was I? Over here, from minus 2 and backwards, that's going to be x is less than or equal to 2. So my two values here, or my range of values even, are when x is less than or equal to 2, or when x is greater than or equal to 6. If we have a look at the marking scheme, that's exactly what we're given. So this was our method number 1. And again, we got our same answers here. That part and that part are the only ones you need. They've sort of used a lot of maths terminology here, but what we've said here is the exact same thing. That's your method number 1. And I'll just walk through your method number 2 as well, just in case you find that easier. You'll notice that this is your method number 2. And what they've done here is they've taken the two scenarios. So seen as, like in my original question, I had the absolute value of x minus 4 is greater than 2. So they've sort of taken the two scenarios and found out what the story was with both of those. So they took the scenario that like x minus 4, so they've gotten rid of their bars now. They've said, well, it's either going to be greater than or equal to 2, but it could also be less than or equal to minus 2. So they've sort of taken the two scenarios of like whether this here is a positive or a negative number. Once they have this here, they just simplified that. They added 4 to both sides to get this value here. Once they had this side here, the right hand side, their x minus 4 is less than or equal to 2, and added 4 to both sides, they got their x was less than or equal to 2. So they got the same thing as up above here in, I suppose, 2 lines of working. But I find squaring both sides in the chapters leading up to this topic, you often get a lot of practice at squaring both sides and working with your inequality. So this method here is consistent with that. Also, with my second method down below, the two different sort of scenarios where this here is greater than or equal to 2, but less than or equal to minus 2. Sometimes it can be hard to sort of visualize, well, what way is my signs going to go? What sign is this going to be? What way is that going to go? What sign is this going to be? So there's a lot of things to consider and a lot of things that you have to sort of visualize yourself. I know the way up top here takes longer. It takes 1, 2, 3, 4, 5 lines, I suppose. But personally, I feel it's a more sort of robust way of getting your full marks. But then again, that's up to you, whichever way you want to use. If we look at just a marking scheme, you got your full credit for correct answer without work. So you don't often see that in a question like this. I'm just going to point you to your high partial credit, which is your 7 marks in this question, your correct solutions to the quadratic. So if you got down as far as here and stopped, you lost 3 marks for not going the one step further. So that would be an awful shame to lose 3 marks for just not finishing the question out. Okay. Last question we're going to have a look at is this one here, and it brings into account not just one function with your absolute value, but 2 of them, and it also brings in a graph. So the first thing you have to do is to fill in the points A, B, C, and D down here, and how they correspond to points A, B, C, and D on your graph. The second thing you have to do is solve your inequality down below here. So seeing as these two questions are sort of tied together, like this is the I part of part B and the I part of part B of your 2014 question. You can sort of mix and match as to like which parts you complete first and which parts you complete second. The two of these parts of your questions, they complement each other, and you can use one to sort of help you sort out the other one. So what I'm going to do first and foremost is I'm going to look for any clues to see is there any of these values that I can fill in just straight away. And the first thing I notice is that g of x is equal to 2. And if you look at your diagram, that corresponds to this straight line here. So basically like this and this are saying the same thing. They're talking about the same part of the graph. And you'll notice that g of x up here is equal to 2. This g of x up here is the same g of x that they're talking about here. They've just written it in a different way. And you know that from up here your g of x is equal to 2. So you know that your y here is equal to 2. So for points A and B, you know that the y part of those points is going to be the number 2. So let's put that in. For point A and B, the y parts are going to be 2. There and there. Points C and D lie on the x-axis and the y-axis, respectively. So for point C, if it's on the x-axis, that means the y part of the point is going to be 0. So let's fill that in. For point C, it's on the x-axis, so the y part is going to be 0. And for point D, it's on the y-axis, so the x part is going to be 0. There we go. So just by looking at the graphs and sort of like working backwards on what we knew about the x and the y-axis, we actually found half of our answers for B part I. Now, I think the best thing to do in this scenario is have a look at B part II. We're going to solve this and then we're going to try and use this to fill in the rest of our points. So I'm going to just skip to B part II. I'm going to try and solve that and then we'll loop back around to B part I. So let me get a new page. The absolute value of x, what do we say, x minus 3 is less than 2. I'm going to square both sides. So x minus 3 squared is less than 2 squared. I'm going to end up with x minus 3 times x minus 3 is less than 4. When I do this out, I'm going to get x squared minus 3x minus 3x plus 9 is less than 4. When I tidy my left hand side up, I'm going to get x squared minus 6x plus 9 is less than 4. When I take 4 away from both sides, I'm going to get x squared minus 6x plus 5 is less than 0. And that's what we'll be working with on my next page. Again, when you get to this line here, you can factorize using your quadratic formula, or you can use your guide number method. I'm going to use my guide number method. And you're going to end up with x minus 5 and x minus 1 is less than 0. So they're my factors, these ones here. So let's just label that factors. So my roots are going to be x minus 5 is equal to 0, which when I add 5 to both sides, I'm going to get x is equal to 5. And my other root is going to be x minus 1 is equal to 0. So when I add 1 to both sides, I'm going to get x is equal to 1. Or, and these are my roots. And again, I've just popped in a graph that I've taken from GeoGebra. Just to point out a few things, your roots here are 1 and 5, which we had found out. The point where this crosses the y-axis is your plus 5 here, which is right there. And as we know, it's a smiley face because that x squared is a positive x squared. Now we want to find out what this is less than 0. So we want to find out, well, what are the range of values for which the graph dips below the x-axis, and it's going to be in between your two roots here. So when x is less than or equal to 5 but greater than or equal to 1, you'll notice that I've done that all in one inequality sort of expression or equation, and that's because there's only one area of the graph that we were looking at. It was that bit there that's in red. In my other question, if I just scroll up to it, you'll notice that I had two separate regions. So this was my last question. This was the other exam question that we did. We had this region and we had this region, and that's the reason that I sort of separated my inequalities over here. However, if you're talking about the bit in the middle, which we are in this question, it's a lot easier to write it as this. So you might ask, well, what does that mean for our original question? Remember, our original question is back up here. By the way, we've solved this question. We've done part II. we've got that x is, let me just go back to my workings out, is greater than or equal to 1 and less than or equal to 5. And if we look at the graph, that should correspond to these 2 points here, because in between like these two values, the 1 and the 5, when x is 1 and x is 5, my my absolute value of x minus 3, which is this line here, or this graph, the one in red, dips below my y is equal to 2, which is my horizontal line. Let me just do that in a different color. Let's go green. This line here. So that's that one. So let me underline that in green. And the red line is, let me just go back to my red marker. The red line here corresponds to the red line in the graph there. So what that means for us is that we know that the x value for my A point, we know that the x value for my A point is going to be 1, and we know that the x value for my B point is going to be 5. So let's fill those in. My x value for the A point is going to be 1. My x value for the B point is going to be 5. So that just leaves us with point C and point D to contend with. And as you can see, I'm just going to get rid of my lines here. Point C and D both lie on the y is equal to fx graph, which is y is equal to the absolute value of x minus 3. Now, if we were to take the point D here, we know that the x value is 0. So we know that y is going to be the absolute value of 0 minus 3, which is 3. So we can fill that 3 in to the y value of part D. In the same way, and just underneath here where I have a bit of room, for point C, we know that that's on the line y is equal to fx, and that's this one up here. So if I just write that out in its simplest terms, we're going to have y is equal to the absolute value of x minus 3. We know that the y value of C is 0, so we know that 0 is equal to x minus 3. So we need to find a value so that 0 is equal to the absolute value of x minus 3. You could square both sides if you wanted to and go from there, but if you can see that if x is 3, then you're going to have inside your bars here, you're going to have 3 minus 3, which is 0, and the absolute value of 0 is 0. If you can see that, then you can skip all that and you can just say that x is equal to 3. And that's the last one of your coordinates that you have to fill out. So I suppose just in summary, for everything in the red box here that I'm just after drawing, there was a little bit of trial and error. There was a little bit of just working with your x-axis and your y-axis. There was a bit of like skipping ahead to the B part I of your question. And then there was just a bit of just looking at the actual functions of the graph and sort of seeing what you had already. Maybe I took the long way around doing that question, but I wanted just to make sure that I was correct in everything that I did. If you were trying that question before and if you got the same answers with a quicker method, then fair play to you. I suppose I was just using all the maths at my disposal for that question. I'll just skip ahead to the marking scheme and you can see what you make of it. Seeing as this was the 2014 question, there's not a definitive guide marks for that. I'd imagine between the whole question, I'd imagine there was about 15 marks going in total for it, but I'm not sure how that would have been distributed. I'd imagine I'd imagine 5 to 10 marks for the first part of your question and the same for your second part of your question. So that 15 could be up to 20 marks even. Seeing as I spent so long going through that question, I'm not going to sort of walk through all this writing here. If you want to go through that, you can pause the video now and have a read through it, see if it makes a bit more sense than maybe the method that I used. But other than that, those were the two questions I wanted to do. So just to remind you, you had a look at a question with just numbers, and you had to find out what x was, or your range of values for x. We had to look at a question with a graph, and we had to sort of sort that out. And just to finish off, your key points for problems involving the absolute value. You're going to isolate the absolute value part of your problem on one side of your inequality sign. That was done for you in most of your questions here, so you didn't have to worry about that. Square both sides, simplify, and just make sure your answers are applicable to your original question at the end. Sometimes if they put a fraction, an algebraic fraction inside of your absolute value sign, there might be an answer that you get at the end that won't work with the fraction. In other words, like you might have, let's say you got 1 all over x minus 2. The condition for this fraction is that your x, your number down here, cannot be equal to the number 2 because of the fact that if that was the case, if x was equal to 2, then in this fraction you would have 1 all over 2 minus 2. And of course your 2 minus 2 is 0, and that fraction would not exist. So if you ended up with like your bars either side, and if you got an answer like x is equal to 2 at the end, you had to make sure that you disregarded that number because of what's said up here. So that's what I mean by the last line here. Just last thing, for my key points, I've said square both sides and simplify. Obviously, if you want to use the other method, I think it was this one here. So taking the positive value and taking the negative value and like doing two sets of sums, that's absolutely fine as well. But just make sure that you're rock solid with that. Guys, as always, I think that's all I wanted to get through today. But as always, if I've missed anything or if I need to clear anything up, I'll put that in the description below. But okay, until next time, thanks for listening, and we will see you later.